Welcome back, everybody. Today we're going to look at setting up the input system for a first-person shooter game. So what we're going to do is I'm starting with the blank project here just to show you there's nothing in the project. I'm not using any pre-built content. And the whole thing, if I weren't explaining it, should probably take less than 4 minutes to set up. But I'm going to walk you through each of the steps that you need and the pieces that you have inside of Unreal and how to access them for this project and hopefully many more. So let's start by adding some blueprints to our project, some things that we're going to need to reference in order to organize our content in a meaningful way at a later time. So I'm going to create a blueprints folder, and inside this blueprints folder, I'm just going to add a few simple blueprint classes. We're going to start off with the game mode. We're going to add a player controller, and we're going to add a player character. You can definitely build more things off the bat, but these are going to get us the base of what we want to be able to organize this information. So I'm going to start by making the game mode use our character and controller. So over on the right of the game mode here inside of the class defaults, we're going to have the player controller class. We're going to choose our BP playcon from that. And then we're going to use the default pawn class as our BP player character. That's all I need to do inside of the game mode for right now. So I'm going to close that down. I'm going to go over to Edit, Project Settings, Maps and Modes, and I'm going to set the default game mode to my game mode. And you'll notice, because of the things that I set up before, that they're populating here for the default game mode. And that's all I need to do. Now the game will, by default, in every level that I ever start, use my character class and my character, my player controller. The problem with that is, that doesn't do anything. My character's not connected to any inputs or any actions. So we need to define not only the inputs that we're going to be looking at, but also the actions that we're going to be taking. So to use that, we're going to lean into the enhanced input system inside of Unreal. So here under blueprints, I'm going to have another folder where I'll just call this input. And inside of this, I'll right click, and under the input category, you'll see these two specific icons, input actions and input mapping context. We'll start off with input actions. Input actions refer to things that the player can do. This is a named action or mechanic or feature of your game. So often things like jump, interact, reload are going to be things that you would associate with input actions. But it's also handling more granular, smooth details like locomotion, moving forward, turning, looking, the acceleration of a car. Those types of things are also input actions. So when you think about the way that the players get to interact with the world, the input action is the game's perspective of what the character or player is going to do. Now, the input mapping context is going to reference all these input actions. You could even see that through the icons, one controller versus a collection of controls. The input mapping context goes and reaches out to the user input and says what button, device, or input system is going to connect to that input action. So the input action is game facing and the mapping context is hardware facing. So we're going to need both of these things. I'm going to create an IMC, input mapping context, and I'm going to call it main, just to name it here because we're only going to have one in this project. And then I'm going to go back up and I'm going to create an input action. Now, the preface for an input action should be IA, and I'll show you in just a second why you should use your prefixes on these. I'm going to start off with IA jump, and I'm going to go in and look at some of these things that you can set inside of the input action itself. For IA jump, you'll see that we have ability to describe it. Player attempts jump action. Right? And so I can give this whenever I look at that input action somewhere else. This is like a tooltip to remind me what this is supposed to do. The name's pretty straightforward, but if you have a little more esoteric or larger scale game, you may want to start adding some tags to details to allow for people to process that. Trigger when paused is an important thing. Like if you want to have the escape key be mapped to resume play, right? So if resume play is something you want, and you don't enable trigger when paused, you'll never be able to unpause the game. That'll be problematic, of course. Reserve all mappings. There's an ability to customize your input with Unreal. I'm not going to get into that today. That's a much deeper topic, but you can have the user define and customize their own keyboard mappings, and so this is part of that. The value type is one of the things we're most interested in the input action. There are 4 types. There's a digital bool, which basically means that it's on or it's off. You're doing the thing or you're not. This is really great for keyboard or button presses because that means they have pressed the button or not. If you have a pressure sensitive button, or you're going to use a like a mouse input or joystick, you probably want to use one of the axis values here. So an axis 1D is just going to be holding some value along x. An axis 2D is going to hold an x and a y, and axis 3D is an x, y, and a z. So if you have something like a gyro inside of a cell phone or something like that, the axis 3D could be used to potentially control the movement of the thing, directing action inside of the game. We're going to leave the jump to a digital bool. There are different triggers that exist in here. For the triggers, you have chorded actions, which allow you to have like multiple button presses. Combos, combos is multiple button presses. Chorded actions is when you do one action that's dependent on another action. So like if I have a charging state and then I have a charge cancel, then I could do the chorded action to relay one to the other. The down is when the thing actually first gets pressed down. Hold might have a duration of how long it's held. Hold and release has to be held for a certain amount of time before release, before it'll fire. Pressed means that it's down and then released within a certain window of time. Pulse means that it's being tapped. Released is only fired when the button comes up, and then repeated tap is the thing has to happen a few times, and tap is that it happens within a short window of time. And so these different triggers are things that will cause the inputs to actually send out an action into the code saying, go ahead and do it. You've met your threshold for how to execute. By default, pressed is the behavior. Sorry, down is the default behavior. Modifiers that we have here, we can look at the dead zone. If you have an axis, say you have a joystick and you want to allow the user to customize the dead zone because they have an older controller and you don't want the joystick to affect their gameplay, they can increase the value of the dead zone, reducing the amount of input that would be detected and considered as the minimal input to execute. FOV scaling, something that would basically allow you to change the value or rate of input based off of the field of vision that you have for the player. So if, for example, you had a game that allowed for the player to have a customized slider for field of vision, and you wanted them to have a fixed rate for turning around that wasn't based on the screen size, it was based on player speed, then you would make an adjustment here. Negate is just going to take whatever that value is and it's going to flip it around. If it's a 1, it's a -1. If it's a 0.5, it's a -0.5. We'll use this in just a little bit here. Response curves, exponential response curves versus user-defined response curves for a little bit more control over those customized interfaces. Scalar values, scale by delta time. These are just different ways to modify the value that's being sent out. Smoothing the data, you can talk to what level of precision you want to smooth or how big of a step you want to take over time. Swizzling the input axis values. This can be a pretty important one. Swizzling just means that we're going to take input that was captured on one axis and we're going to rotate it to a different axis. So it remaps the X, Y, Z coordinates to other values in case you need to connect them to a different input, or things are inverted, or there's a hardware mapping that you can't bypass, that you have to do it somewhere inside of Unreal. And then world space mapping as well. So we don't need any of those for the jump. Jump is just going to stay as a Boolean. The lower priority inputs, we want to be mindful that there is a potential in the system to overload a button to do multiple things at once, and that may be exactly what you want to do as a developer, but sometimes you don't. Sometimes you want to say you have to choose one action, and then you're going to override certain priorities. For example, X to interact, X to reload, X to have a conversation. Which one is the higher priority? Do you want the player to interact with the switch that shuts down the bomb, or to reload while they're watching the bomb explode, or to have a conversation with somebody while there's a bomb exploding and enemies coming at them and they haven't reloaded their weapon? So setting up the priorities for how they're going to interact, you're going to want to be able to define which thing is going to be able to consume a lower priority. And the lower priorities are set through a value. All right. So we have that one input action. I'm going to go ahead and attach that to my IMC so we can just get jump working to make sure that we fully understand the process. So here I'm going to go double click on the IMC, and you'll see that it has a number of tabs here. We're going to start off by just expanding the default key maps. And you'll see that there's a mapping, so I click plus here. And when I click plus, there's a drop-down menu that's going to let me choose any of my input actions that exist inside of my game. So I'm going to choose IA jump here, and then when I expand that out, that's going to give me the option to assign it to a key. I can go through this drop-down menu, look at any gamepad, keyboard, mouse, or other input system, right? Or if I have the input system connected to my system while the system is on, I can just click on this little keyboard function here and press the key that I want, and then it'll map to it automatically. And this is true for controllers or joysticks, hat switches, things like that. So if I come over here, let's see, I'll add one here and a middle mouse button, right? That picked up pretty easily. So spacebar will fire off, and then you'll notice that here I have triggers and modifiers inside the IMC as well. So I might want to inherit the settings from the actions, or I might want to say I have jump can be put to spacebar, but maybe also jump would be set to something else as well. And then I want to have some modifiers specifically for that input. So I can set up the controls. Jump is going to be jump, and I can set this up for a PC, for a PlayStation, for an Xbox, all in one go. And I don't need to modify it anywhere else, just this one place. All of that, the code is going to respect what platform I'm on, and it's going to execute the right action. All right, let's go make the character jump so we can verify that our IMC is set up correctly. I'm going to open up my other blueprints. Specifically, I'm going to go to my character, and I'm going to go to my event graph to look at the blueprint for this. I don't need any of these. I'm going to go and just create my input action. I can right click, type IA underscore, and you'll see that my jump is there. So this is going to get me the value of jump. Either it is active or not active, but this is actually going to give me the event. Notice the diamond with the arrow on it. So when I click on this, it's going to get me a red event node. And if I expand this out, there's a number of execution lines that can follow through this. If you remember, I talked about the different trigger types that exist in enhanced input action. So those different trigger types are going to cause different nodes to be, or different lines to be fired at different times. So when it's triggered means that it has met its requirements for triggering. When it started is when the input has begun. While it's ongoing is before or after it started, before it's been completed or canceled. Canceled is if you have some sort of interrupt to the input that even if they're holding down the button, it's no longer considering it as viable. And completed is when it has resulted in a full triggered execution. So not during the trigger, but afterwards. And then we have the action value, how long it was going on, the amount of seconds it was triggered, and the actual object reference for the input. So for us, we just want to have when started. And when it started, I'm going to click off, and because I'm using the character class, I can just type jump. And you'll see that node pops up. It's looking for the character, and this jump feature is built right into the character class. I don't need to do anything. If I wanted to modify how the player jumps, I can come over here, and you can see all the different jump heights, the force, the aerial control, boost multipliers, things like that. So that's all built into the character. So I have some control over that. We just want to make sure the character does jump. If I want to go play right now, the character won't jump. Even though I've mapped it up, I have jump set up to spacebar, and I've attached it to the character. When I press space, nothing happens. The reason is that we are not using the IMC right now. So the input mapping context can be added to and removed during gameplay. Imagine you're going through a tutorial and they only want you to know how to jump before they teach you how to duck. They only want you to know how to jump and duck before they give you weapons and melee combat and inventory management. And so they only expand the buttons that allow those features as you go on, and so they're adding to the IMC. And if they decide at some point that you've lost some resource, then they can pull a resource away from the IMC. So we're going to go to manage that. That's in our input. And if you think about input, you should always think about your controller. So I'm going to set this up to be on event begin play. We're going to need a special node here called the enhanced input subsystem. So we go input subsystem. So we have the enhanced input local player subsystem. I'm going to grab this one right here. There's one from the player controller, but this one will work as well. The one from the player controller just needs you to define the player controller. Since we're in the player controller, we can grab this one, and that's just fine. We're going to add mapping context. So when I choose add mapping context, I want to wire this up to my event begin play, and then I want to select the mapping context, the IMC that I have created. And now, when the character controller is loaded, it's going to also add the mapping context to the local player subsystem. We could also remove context, right? So we could remove a context if we decided to add 3, 4, 5 of these things and then later pull some of them out. And that's something you might want to look into for games where you have a lot of different equipment that gives you different abilities and the controls change between them, or you have different modes of play like being on foot, in the air, in vehicles, things like that. So I'm going to compile this really quickly, and we're going to go test. So let's do a new editor window, and let's see if I can jump. I clicked in, I can jump. Now we know my IMC is working. I've been able to test that effectively. Now I can't look or move, but I can jump. So I know that this part is wired up correctly. I'm going to jump back to my my content browser, and I'm going to create all the other input actions that I'm going to want to use here. So let's go back to our input, and I'm just going to copy this one with a Control D. And we're just going to say IA locomotion, and I'm going to step into there right here. When I hover over it, it says value type Boolean. If I want to move, I don't want to be moving or not moving. While on a keyboard, that's technically true. I want to be able to capture the rate of movement. And so rather than having a digital Boolean, I want to change this to an axis value. So I'm going to get a float value out of this, and that's going to help me determine when I tell the game that I am moving, that I have a number to work with, so it can let me do some math on it. So now that I have that, I can duplicate this, which is an axis value, right? If you look down there, you see axis 1D inside of the little hover over details. And I'm going to say IA strafing, IA look V for looking vertical, and then IA look H for looking horizontal. And we can take our jump and duplicate this as well. We'll say IA primary. And then I can take all of these and go into my IMC, and I'm going to add each of them. So my mapping, I'm going to go locomotion, strafing, look H, look V, and primary. So for primary, I'm just going to make it left click. For locomotion, we're going to open this up, and I'm going to add another input to this, and we're going to attach this to both W and S, because we want to be able to move forward and backwards. So if W and S are both input, then I want to be able to control which direction I'm going based off of that input. So I need to take the S value. Right now, they both would return as true or false, right? This is going to produce a 1 value. This is going to produce a 1 value. So I just come down to my modifier for S and just add a negate to that. So whenever I press S, it's going to give me the value of input in the opposite direction. I'm going to do the same thing for strafing, where I'm going to add 2 values. It's going to be D and A, and I'm going to negate the value for A. The reason for this is that in Unreal, X forward is positive and Y right is positive. So we want to take our left value and make that negative. And then I have my look H value. And so for this, I'm going to attach that to mouse X. And for the look V value, I'm going to attach this to mouse Y. And I'm going to invert this. And I know that seems a little silly off the hand to run inverted. I don't play inverted. In fact, that's exactly why I'm doing this. If you are in a first-person game, the logical control is that pushing the mouse forward on your desk should make the character's eyes go up, because the desk is a mapping of the screen space in front of you. So forward is up, backwards is down. This is different than it might be in a third-person or flying game where you have joystick control where you're actually tilting offset or you're tilting camera direction. So just be mindful of what conventions you're leaning into and make sure your controls reflect those appropriately. All right, now that I've set these up, I have all the mapping context controls, but I haven't actually done anything inside of the player character to get these to do anything. So now I'm going to go over to my player character, and I'm going to open up my palette, and I'm going to have in my palette a search for IA underscore, and now you can see all my functions over here. Having them labeled properly with the prefix is giving us the ability to just click and drag all these elements out there without too much hassle. I don't need to type a bunch of things. I can just go once and grab all the pieces that I need. All right, so for whatever we're going to do with firing, that's whatever your game does, right, for the primary input. So left click to do whatever, E to interact. We're going to look at the core movement that goes along with the first-person game. So for the first-person experience, we're going to start with locomotion, being able to move forward. So if I want to move forward, just like with the jump, I want to be mindful of which exact line I'm going with. If I set it on started, that means pressing W will only move me forward that instance that I press forward. So I'll have to tap W to keep moving. What I'd like for locomotion is to have a triggered value that's going to add movement to my character. And so you can see here we have a function called add movement input. When we add movement input, if we hover over this for a second, it's going to be given in a world direction based off of whatever vector we input. So this world direction is going to be the orientation of where the player will move in relationship to that that point. So the world direction is just a unit vector typically. You can give it a larger vector, but it's going to treat it as a single scalar. So what we want to do is take the world direction, and I'm going to pull off from that, and I'm going to say get actor forward vector. So the actor forward vector is going to immediately reference self. So the player character in its forward vector is going to determine where W is going to move. And then the scale value that I get from that, its default to 1. So if I start to play right now, it should, let's see here. When I press W, it's just going to move forward at that set rate. So I want to feed this a value because if I come back and I press S or W, and give me 1 second to turn something on real quick. We'll turn this on. Okay, so now if I'm playing, you guys can see. I'll put this to select a viewport. You can see I'm pressing W and it's going forward, and S is also going forward. See in the bottom right corner, you can see my inputs. So in this, if I wanted to modify the code more effectively, then I'm going to want to get the value out of this, because remember, the S is returning a negative value and the W is returning a positive value. So now when I go to play, you can see W and S are producing the expected results where I'm going forward and backward appropriately. So the value that I'm getting out of that matters. With the jump action, it didn't really matter because I was either doing a jump or I was not doing a jump. I can't jump while I'm on the ground, so jump function is taking care of that scenario. When I have the enhanced input for locomotion, I want to make sure that not only am I getting the correct direction on my vector, but I'm also getting the correct direction of input. We're going to be able to copy the same pattern over to use for the strafing, except for I'm going to use a different vector. So for the vector for this, if you can follow the logic, instead of going from actor forward vector, I'm going to use get actor right vector. And so get actor right vector is going to allow us to understand the area that is to the right of the player is positive and to the left of the player is negative. And so when I use the value, D should produce the positive result, as that's what I configured here. And then A should produce the negative result, as that is the modifier attached to that input. So now I should be able to move forward and strafe left and right. There we go. All right, so let's get back to this and let's take care of the look H and the look V. So looking horizontal, what games used to only do, we're going to use a special control for this that's called, if I can get there, it's called add controller pitch input. And so we have, I'm sorry, that's incorrect. It's the yaw input. It's much like with a flight stick. So if you have an airplane, when you're moving lateral from left to right, you're pivoting on a yaw, and when you're going up and down, that's a pitch, and when you're barreling one side to the other, that's called a roll. So you have control for the camera yaw, pitch, and roll, along with the inputs that you have here. So attaching trigger to these values, that's all we need to do. And we should comment our work. Put this down here. All right, so now that we've commented and organized our code, we can come back, play, should be able to move forward, move backward, move left, move right, look up, look down, look left, look right, and jump. I now have the basis of most first-person shooters, most first-person adventure games, platforming games, and you could apply these same principles. If I add a character to this and I move the camera away from the character, we can, explore making this a third-person experience. Very, very grossly. I'll attempt that here in brief. So if I take a spring arm and I add a camera, and then let's make the character a cylinder. Why not? Let's get the cylinder a little bit closer to what the character is going to be represented as. And then we'll take the spring arm, move that up, and then we'll have the offset over here. And we'll take the camera and we'll just pitch it down a little bit. So now if I go to play, I have a third-person character moving forward and backward, moving left and right. You notice that I can't look up and down, and that's simply just because for the spring arm, I want the pawn control rotation. There we go. Now I can look up and down. You just got to be careful about what you're controlling with that. And so the ability to build a character class, build a character controller. It's very accessible. The input system is extremely robust to allow you to do a number of different types of games and to be able to publish the same game without too much technical headache onto multiple platforms, at least from an input and user experience standpoint. So I hope that this has given you an idea of what to do to set up your basic character controller, give you an idea of what the enhanced input system looks like, and allows you to go out there and keep building.